Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 33, Acid-Base Equilibria, Part 2. Here are our objectives for today's video. Pause here. So whenever you have just a weak acid, we can just use an icebox and solve for the H3O plus concentration to get pH. Or if it's a base, we could use Kb and we could find the OH concentration and convert that to pH. But when you have a buffered solution, it's a little bit more complex than that. So we have this equation called the Henderson-Hasselbalch equation that is used to calculate the pH of a buffer. So the pH is just equal to the pKa, the pKa being the negative log of the Ka, plus the logarithm of the ratio of the conjugate base over the acid. Pause here. So based off of this equation, what we see is that the pH of the buffer is really just determined by the ratio of HA to A minus and the Ka, but not actually by the quantities of each. So that's how we determine the pH. But the buffering capacity, meaning how much acid or base that a buffer can handle, is determined by the concentrations of HA and A minus. And just a third point, although it logically makes sense, you're going to want to pick an acid for your buffer that has a pKa close to your desired pH. The reason for that is that you can have approximately equal concentrations of HA and A minus, so you're just as able to buffer an acid as you are to buffer a base. Pause here. Okay. I'll work through this. I got that my pH was 5.65. Pause here. I'm going to wait 7 seconds and then say the answers out loud. So for the first one, when HA is equal to A minus, the pH is going to be equal to the pKa, which the reason for that is if A minus over HA is equal to 1, the log of 1 is 0, so pH is just equal to pKa. For the second one, if HA is greater than A minus, then the pH is going to be less than the pKa. The better way to approach this would probably just to recognize that you've got more acid than base, therefore the pH is going to go down. But mathematically, it also works out with the Henderson-Hasselbalch equation. And then for the third one, if A minus is higher than HA, then the pH is going to be higher than the pKa. Okay, here are our practice problems for today's video. Thank you so much for watching and have a great night.